So to begin with, who are you?
So my name is Merlin Carson. I am a graduate student at Portland State University on the AI track, specifically focusing on deep learning.
Okay, so what specifically does that mean? Like, what do you do during the day?
So I have classes that I take. I'm currently taking a deep learning course at Oregon State, OHSU, Oregon Health Science University. I am also taking an AI course at Portland State University. So one class kind of focuses a lot on deep learning architectures, and the professor specializes in audio research. So a lot of it is covered from the perspective of audio. The artificial intelligence class is more classical AI, so it's a lot of state space search, and a little bit of introduction to machine learning. But there are more specific machine learning courses at Portland State University. I also have a research position in a advanced compute lab at Portland State University in the computer engineering department. And I research algorithms for the identification and localization of radiation. And so I spend a lot of time reading research papers and looking for ideas to improve algorithms. I personally focus on the identification aspect of it. My lab partner works on the localization part of it. This is a computer engineering lab, so we do a lot of hardware-based neuromorphic architectures, and which are basically neural networks that are hardware-based neural networks. Which are much more power efficient and speed efficient than computing resources. They still don't have quite the accuracy, and you can't do as much of the performance tweaking that you can in software, but they run much faster and they take a lot less electricity to run, which is currently a big problem. Our compute resources are scheduled to use all of the world's energy in the next 20 to 30 years. So a lot of research is going into how we can develop low power computers and computing, especially with all these gigantic data centers that Google is coming up with and everything. So I spend a lot of time researching and implementing these algorithms for identifying radiation for a project that's funded by the Department of Defense. And so that involves a lot of research papers and a lot of experimentation.
Have you done any work in the industry at all in your graduate study work?
So yes, I started about 3 years back. I did an internship in a program called MECOP, which is something that is a statewide program that several of the universities in the state, OSU, Portland State University, participate in it, and lots of companies around the state and even outside of the state, a lot of large companies like Intel and Dell basically are looking for interns. And I got an internship at a local audio company called Biamp. And so I was actually lucky. They were looking to start a new deep learning project. And so I've actually worked for them for about 2 years, working on audio signal processing using deep learning.
Very good. So obviously you're at Portland State University. Are there other places that you've studied any of this?
Well, Portland State University has actually done a very good job of adding to their curriculum in the last few years. So I have done quite a bit of study there. Through my research position, I've done a lot of self-study. I'm currently taking classes at OHSU. They have good deep learning classes there, machine learning and deep learning classes. But really, I got into this on my own. There are a lot of online courses, Coursera, Fast AI. There's a lot of really good courses online for learning about machine learning and deep learning. This is a very popular field right now, a very big up and coming field right now. Currently, there are more deep learning and machine learning papers that are being published than any other type of paper in any industry. So there's a lot of resources online. There's a lot of what I would call, tinkerers out there that are interested in this and just kind of learning it on their own. I actually started by reading some Wikipedia pages that showed how to develop basically all the mathematical algorithms for a neural network, and showed you some examples for some hand-drawn examples for doing backpropagation. And I implemented my own neural network from scratch in Java just through some equations on a Wikipedia page.
Very cool. So we're going to be speaking to high schoolers, obviously. So what do you feel like kids should know going into something like this? Like if you think back to like yourself back in high school age, like what kind of advice would you have given yourself from that time?
So to begin with, I started learning to program my high school year, my freshman year of high school. There was a programming class, an AP programming class meant for seniors, but I was really interested in computers since I was 5 years old. So I started taking those classes my freshman year of high school. I started taking C programming classes at my community college, Lynn Benton Community College, my sophomore year of high school. So one thing that I found early on, I was always, decent at math, but not super interested in math. I did fine with it, but was never like my favorite subject. And in very elementary stages of learning computer programming, there was not a lot of math involved. You're kind of learning syntax and you're writing loops and print statements. And so early on, I did not really understand the association of math and programming. Obviously, the computer is doing some binary math in the background that you kind of learn some basic stuff, but you don't really pay too much attention to that early on, which is another thing that I didn't learn very well early on was binary math, because I was, we have these high level programming languages that do it for us, so it doesn't matter. It wasn't till I started studying AI, and I actually got a job straight out of high school as a programmer. But it was basically a very nice framework set up to develop these systems, and it still continued to be a lot of syntactical stuff and not a lot of math involved. It wasn't until I got into AI that math really started getting important, and I started realizing how important math is. And especially for AI, because there's, a lot of linear algebra, a lot of calculus, especially linear algebra. Another thing I was really interested early on was computer graphics, but I did not really have the geometry and the linear algebra background to really understand how computer graphics works, especially in modern computing. And so there's a lot of really interesting aspects of computer programming, not just AI, any type of graphics or signal processing. It really helps to have a good understanding of math. And so I really recommend focusing a lot on math and just getting good at it. It really helps you not only with, developing algorithms, troubleshooting algorithms, but really understanding a lot of the high level code we use these days lets you abstract a lot of that away. But if you don't really understand what's happening under the hood, it's hard to understand when things aren't going right, what's going on or why it's doing something that it's not. And a lot of this stuff too, especially with current AI and deep learning, there are a lot of these great fancy packages in Python that do a lot of this stuff for you. But in industry, Python is not used in industry. Python is a great prototyping tool to develop algorithms with, but it is really slow. And so a lot of this stuff has to be written from scratch in C and C++ or Java, a compiled language that is significantly more optimized. And a lot of those don't have these packages pre-written to do this stuff. And so a lot of this stuff has to be written from scratch. And so you can do a lot of really fancy, fun things in Python, but at the end of the day, you're probably going to have to, if for a job, you're going to have to really do some low-level math programming to actually in a real industry job.
Fair enough. So let's take a look at like what a day looks like for you. Like what do you think a typical day would look like if somebody was like looking at what their life would be like if they were in your shoes?
Well, so you mean what I'm currently doing right now or just in general industry wise?
Why don't we do both? So let's start with today. What your current days are like?
Well, Today is not the best example because it's a Friday and I don't have classes on Friday.
Fair enough.
Um, and also it's a little bit different because of the current state of the world. I work from home, and so I'm a little more flexible when I work and what my hours are. Um, and honestly, I predict this will even once this is over, this will continue to be more of a norm. I think in the late 90s, early 2000s, we started pushing towards this work from home. And then people were like, well, wait, now we have this agile where we really need to get together all the time to like talk and figure out what to work on and then go off. And so it kind of went back to offices again for a lot of people. But I think people are starting to get used to this. A lot of businesses are seeing that this is successful in a lot of ways, and that it saves a lot on office space not having employees in a building. And so I think more and more Zoom has really adapted to this new environment. So I think more and more we're going to see this work from home, work remotely, especially for our industry where this is possible, which will give people more flexibility on when they work. So most of my specific times are related to either when I have a class, which Monday through Thursday, I have a class from 10 to noon. So that's a specific time I have. For my lab, I have meetings twice weekly from like 4 to 5 o'clock. That's another thing I specifically have to do. The rest of the day, it's kind of up to me when I'm doing my work and homework. It's fairly flexible because I'm working from home. I don't have to be somewhere at school, in the lab at school working, or in an office working.
Mhm.
So it's fairly flexible. But generally after class, I probably do checking in on emails, communicating, responding to emails, just catching up on what's going on with the people I'm working with. Some responding to helping other people with homework and classes. And then from there, I kind of alternate back and forth between doing homework, which is right now implementing different deep learning architectures and different classical AI algorithms, and then doing research, which for the most part, I'm currently working on some papers that are in the review process. So basically dealing with kind of peer reviewers and feedback from peer reviewers. Hopefully going to have some published papers here soon. So I've been spending a lot of time writing, a lot of LaTeX. That's been really helpful. And as another thing I highly recommend, especially in this industry, because you'll probably be doing a lot of research papers. It's also very helpful for doing homework with the math work, especially. Um, there's a little bit of a learning curve, but once you do it, it's much easier than trying to use math editors and Word and other stuff like that. And formatting and embedding images is really nice. So I spend a lot of time working with LaTeX. So because I'm in that phase, I'm doing a lot less programming than normal for my research position. But for classes, it's kind of, in a way, this actually, because of these online classes now, because we're all doing everything remote, we've actually gotten a little bit more away from doing exams and a little bit more towards spending time on programming projects. So in a way, I like that personally. I think exams are not necessarily the most helpful thing. I understand it's important to be able to assess students and for them to understand where they are, but I think ultimately we're trying to learn to be programmers, and so we've gotten to spend more time focusing on programming assignments and programming projects and less on exams. And a lot of these midterm and finals exams take a lot of time away from learning new things in order to reinforce what we've already learned.
My data structures kids will love that you said that. So, um, okay, so that's a typical day now. What about like when you were doing your internship with?
So when I was doing my internship, that was a full-time internship. I took 2 terms off of school in order to do that. 6-month long, 8 hours a day. I basically show up to work at 8 o'clock or 9 o'clock in the morning. That once again, you start off reading emails and responding to emails. a few times a week we'd have the morning meetings, agile meetings, kind of catch up where we are and see what everyone's doing. And then, basically we had, a Scrum board and we had tasks that we needed to work on. I think the one thing that a lot of people don't realize and understand is even though there is never-ending programming work to do, I would say I probably spent less than half of my time actually programming,
Right.
which is unfortunately is what I like to do and would prefer to do. I spent probably the second most amount of time I spent was documentation, and not for end users, for explaining to my coworkers how my code worked, how to set up applications, how to be able to run applications. It's really important to document everything you do. We do code reviews, and so everything that I would finish, one of my colleagues would have to be able to run and show that they could get it to run also, and that they just don't take my word that it's correct, so they
Right.
have to, it really helps to have someone look over your code, because you spend a lot of time getting in the weeds of something, and it might work for what you're using it for, but that doesn't mean that there's not an obvious bug or a pitfall that you're missing. So it's really good to have someone else review your code. There's also a lot of turnover in this industry. This is a notorious industry where people are constantly changing jobs, and a lot of these companies, it's really important for them to be able to continue the projects and the previous work that previous employees have done. So that documentation really helps when new hires come on board, that they can take over where you left off and not just have to start over or be reading your code and hoping that you gave it good enough comments.
Right. So it sounds like logic, math, well, programming is at the top, but close behind is logic and math, and
Yes.
then communication, and then
Yes.
writing. So how many of these skills do you feel like your high school did help you with?
Well, I would say, one thing that I found in high school is you kind of get out of it what you put into it. That high school in general was not difficult to get through and get pretty good grades in. But if you don't really care and you're not really interested in the topics, like you're just kind of like putting in the work and then forgetting about it. I like to write in high school, but I was an awful writer. Communication, I had a class on a presentation class, that we had to do a certain amount of presentations to the class. I enjoyed doing that. I was not good at it, and I also didn't understand both of those classes. I'm like, I want to be a programmer, I don't need to be good at communicating,
Right.
like the traditional thought of a programmer is someone sitting in some dark corner and not talking to people very much. If you look at job positions right now, every single programmer job that you will see, one of the things they're looking for is a good communicator and a good writer. It is something that is extremely important. We are no longer in this age where they have one programmer goes and does everything. Everyone is working in groups. There's a lot of people, a lot of times a developer will need to be part of the sales team to even communicate with the customer and have the customer communicate back what is desired and if it's even possible, because a salesperson doesn't know necessarily whether something is even possible to do, and you don't want them committing to something that's going to take too long or be impossible. So there's a lot of positions where programmers will have to help out marketing and help out sales. And so it's really important not only to have intercommunication within your programming group that you're working for, but also be able to talk to customers and in other professional settings. There's a lot of research in the AI and deep learning community. So a lot of times they will send you out to seminars and conferences, where it's really important. A lot of those talks are pretty time frame limited, so there's only so much they can tell you the real details come for when you ask questions or when you talk one-on-one on the floor with these people. So you really have to be comfortable communicating. You really have to be able to be good at writing procedural documents. I took a technical writing class early on in my college career that was extremely helpful, and has continued to be extremely helpful for me. So yes, those are very important skills that I believe I learned the building blocks for those in high school, but I didn't take them seriously in high school. And a lot of that stuff I kind of didn't pay attention to after high school. And I think if I had realized the importance in this career of them, I probably would have put more energy and thought into it other than what is the minimal amount of work that I can do to get an A in this? Because that was my high school goal, was for everything other than programming, because programming, I would come into the computer lab on all of my breaks and all of my free time and spend all of my energy programming, and everything else was, what is the minimum amount of work that I can get an A in this class? Not, this is something that's important that I need to learn and retain.
Excellent, excellent answer. All right. I think that's all the things that I wanted to go over. Is there any final words of advice you might give anybody?
So we were talking a little bit before the interview about trying to understand and learn about the different aspects and types of programming. And I think that is one of the goals of these interviews, is to show people what is out there, that programming is not this esoteric thing, but there is especially in this modern age, almost everything around us uses some type of programming, and this industry and the need for programmers is going to continue to grow at a very fast rate. However, because of that, it is a very complex industry, and it's not good enough to just learn how to program. If you really want to get a job in industry, especially after graduating from high school, or graduating from college, you have to actually be very familiar and have experience with a very specific type of programming. So it's really important to learn what type of programming that is interesting to you and spend some time doing projects. What I've done is, for a lot of my classes that were not machine learning or deep learning related classes, when I can pick a project, I pick a project that is focused on that class, but that is a machine learning or deep learning projects. So I've gotten a lot of experience and focus in deep learning and machine learning in classes that were not machine learning and deep learning. And so if you want to do web programming, you can do the same thing. Almost any class where you pick a project, you can make it a web-based project. If you're interested in databases or any type of data science, there's a huge field and different types of programming. And you really need to kind of find your niche and what interests you. I mean, that's going to be the other thing that's going to be very important, is if you don't want to get burnt out or bored, is finding something that you enjoy doing. Just programming itself, if you're programming something that's not interesting to you, will get really boring and tedious very quickly. So I highly recommend finding a focus of a type of programming that you like. Not only doing your own research and in your own free time learning about it and doing your own projects, but also college is basically set up to introduce you to a lot of topics. So by the time you graduate, you can kind of pick what's interesting to you. But the sooner that you figure that out, and the sooner you start focusing on a specific type and aspect of programming, and as you take classes, picking projects that are related to that, the more employable you will be. Because employees are going to not just ask you, employers are not just going to ask you generic questions like and theory questions like you learn in school. They're going to ask you very specific questions about the industry that they are part of and the type of programming that you will be doing for them. And if you can't answer very specific questions, and yes, a lot of employers are not going to they're not going to expect you to be an expert in it, but they're going to want you to know the terminology. They're going to want you to show, and especially show projects. I think it's another thing. it's very important to learn Git very early on and start a GitHub repository. Not only is that going to help you a lot with your troubleshooting and revision control, but it's also going to be a place where you can store publicly projects that employers can look at, and they can see that you've done a variety of projects in the same domain that of the position that you're applying for or the company works for. So I highly recommend trying to decide not this you want to be a programmer, but what type of programming you want to do, and try and focus on that as much as possible whenever possible.
Okay. So very much a portfolio then of your work is what you're talking about with Git.
Yes, and
Okay.
I think, you know, the portfolio, I think some companies focus more on a portfolio than others, but the portfolio work will give you something to talk about in an interview. And so when you in an interview, they're going to ask you what types of projects related to the job you've done. And it's also going to help you understand terminology and be able to answer questions. In an interview, they're not going to ask you such specific questions that if you can't answer the question perfectly, that you're not going to get the job. But if you just don't even understand the question, you're not going to get the job.
Right.
So if you have a portfolio, especially in the industry related, it's going to help you be able to comfortably answer questions in an interview without looking like you just don't know about what they're talking.